All right, folks, I'm ready to get started. Welcome back, everybody. Welcome to our fourth week together, the final week before the first exam. So things are about to get serious, even though they have been serious since the first day of class, which is, I hope, the approach you've been taking. But nonetheless, there is still time for you to uh, get serious if that hasn't happened yet. But I'm sure the majority of you are already there, if not beyond it. Happy Valentine's Day. Thank you for spending this romantic night with me talking about managerial economics. I'm sure it's going to be a wonderful Valentine's night for you and for me. But no, the night will end and you can leave and do things that might make up for it. But there's always other times as well. When you're in school, like, school is a priority. It is what you do, and everything else comes after it. And that is the approach you have to take if you want this to work out the right way. So make sure that no matter what is going on in your life, that this is the thing that is happening, and then everything else like kind of just like happens after this. Um, all right, so we are going to finish. Well, I mean, cover all of chapter 4 today, and it will be the last chapter that is going to be covered for the first exam. The first exam will be a week from tonight. It'll take place at the beginning of class. It'll cover chapters 1 through 4. I'll send an email about what you'll need for it, but just to say here, you'll need green Scantron 882-E form. You'll need a calculator, so make sure you bring a calculator. No graphing calculators are allowed. It should be a scientific calculator. No phones will be allowed at all. So even if you have the function for a scientific calculator on your phone, you also have the ability to save the entire textbook on your phone. So therefore, you cannot have your phone out ever. If I see a phone out, grounds for failure on an exam. And also keep in mind that because our weeks are all sort of encompassed within one night, one meeting a week, after the exam, we'll start a lecture for the next part of the course. So just keep that in mind as well. There are practice exams online. They've been there since the beginning. So hopefully you've been checking them out, kind of getting an idea of what you should be doing in terms of preparing for the exam. Gesundheit. If you don't know already, there are 15 multiple choice on the exam plus 4 open answer questions with multiple parts. Those open answer questions can be fill in with some answer. They can be computational. Generally, they will be computational. You will have to compute things, do some math. They can ask you to explain something on a graph, or maybe just identify something from a graph. Things of that sort. Those questions come from demonstration problems, the homework problems, and the practice exams. So, and which those were made up from the same source. So really, homework problems and demonstration problems are your main source for those. And then the multiple choice are conceptual, the terminology, the principles. If you understand these things in the way that I hope you've been understanding them as we've been moving through the first 3 chapters, then you should not have much problem there. But of course, it does require, several passes in the material. So ideally, you've been doing what I've told you should be doing from day 1, which is after we finish each chapter, you kind of take your notes, go through them again with the lecture or the book, fill in parts that maybe were a little not kind of weird or whatever, you didn't get everything down clearly, and then transcribe them to like one page front and back, write small, whatever, put as much information on there as possible. And then that's your study guide for each chapter. So ideally, by now you've done that and you've got study guides for each chapter. But if you haven't, there's still time to do it. And then that's something you can just start going through, kind of figuring all the concepts out. And then, of course, the computational stuff, that's stuff that you have to practice. Like you have to really just kind of hammer it, make sure you understand how the problems are done, and then you should be fine. You have everything you need from me to be able to like learn this stuff if you choose to spend the right amount of time on it. You have the videos that explain how to do the homework problems. You have the lectures that are recorded for you, so you can go back and check any topic that's been covered for clarification. Keep in mind, as I've mentioned before, office hours are not for me to explain things to you because the lectures are for that, and you should be coming to lecture and asking me things as I'm presenting them to you. And if you're not doing that, you should be going through the lectures as though you are in class. I'm not going to help you cram for an exam, so don't come to my office hours hoping for that. Not going to happen. And that's pretty much it, I think, with respect to that. Yeah. So are there any questions you'd like me to address about any of that stuff before I move forward with today's material? All right, cool. So the homeworks have been opened up for this chapter and the previous ones. The prior chapter homeworks are due, I think, tomorrow. Tomorrow, right? So hopefully you've gotten those out of the way. Hopefully you've gone ahead as I've asked you to, because it's a good idea, given that the first exam is going to require you to go through a lot of material. But still, if you haven't done anything I've asked you to do, a week is a good amount of time to do a lot. So, don't leave it till the last day. Start tonight. You got to make sure you know everything. And then right before the exam, you review what you know versus like you leave things to the end to like really understand. That is where it becomes a problem, when you start to try to figure things out the last moment versus like just recall what you already took the time to figure out, because you don't know how long it's going to take you to figure something out. You have no idea. Like it may take you a whole day to figure out, one concept. I don't know. It depends on like where your mind's at, like if you've been tracking the information, etc. So never leave it to the last moment. If you do, accept the consequences of your actions. In the end, it is an exam out of 3, but exams are how your grade is determined in this class. Everything else just supports it. If you fail all 3 exams, you fail the class. Even if you get an A on the paper and an A on everything else, like you fail the class because you've demonstrated that you have not learned a thing, and you've just done some assignments and follow some silly policies to make sure the class runs properly. Like, you need to be learning this stuff, and it needs to show in your exams. So your exam will determine your grade, but if you falter on an exam, it's not the end of the world. It is a part of your overall grade. There are opportunities to bounce back. I'm not saying, depend on that, but the point of mentioning that is to like realize that like you shouldn't let like pressure and stress and fears get to you ever around the time of exams, because then that will affect your ability to just kind of clearly like kind of go through the material and learn the stuff, and then just kind of have it and be confident that you have it, so that when you're going into an exam, you have a clear head, versus the fear of failure, like impairing your ability to just kind of like do what you can do given the amount of time and effort you are able to expend, and then letting that kind of result in whatever it naturally will result in. So do your best, do your absolute best, and then we'll see what happens. We'll continue on, and you'll learn from your experience in a variety of ways, and then ideally you'll adjust accordingly, or you'll keep doing what you're doing, and that's great. A lot of you are going to succeed, and things are going to go well. For the majority of people in this class, things will go well. For a good amount of people, things will go very good, and then for some people, it's not going to go good at all. And that might be the people that are not here right now, and it's likely that it is some of those people. But for just you that are here, like, don't let that happen to you. Put in effort. Take this seriously. Don't make this a waste of your time and your money. Make the most of it. Yeah. So I'll send out an email tomorrow when I post all this stuff, kind of reminding you of what you need for the exam and whatever. And that should pretty much do it. Any questions now? All right, cool. All right, so today we're going to cover the final chapter that we're covering before the exam throughout the entire day. We'll take a break at some point. So this model is like the workhorse model in business for studying like decisions by consumers to consume, given that they are restrained by the fact that they have incomes that limit their ability to buy as much as they want, and also that they face prices in the market, which also help to sort of ration the scarce goods that exist in our economy. Um, and so the components of the model are two major ones, and then of course they have their own intricacies. One main component of the models is of this model is a consumer's preferences. So like the first part of the chapter we'll cover is consumer behavior. It's a way to try to capture the concept of like our preferences in a way that at least is general enough so that we can say something general about the way people interact in markets with prices and what they prefer to consume versus not prefer to consume. So in order to do that, you kind of have to set up some rules for like what it means to have preferences. And so that's kind of what this first part is about. You may have seen like indifference curves. You may have heard of utility functions before. All these things will come into play in this first part, and it's all meant to capture like, again, like sort of this abstract behavior that we all exhibit, which is our preferences for things. We prefer this one thing over something else. It's very subjective and it changes from one individual to the other, but like the model is just meant to capture like a very general case of what like preferences are. And so I'll go into fine detail describing, the model, how the model attempts to sort of simulate that and capture that behavior. And then the second part of the model is the constraints that are placed upon us by, again, the fact that things have prices and we have an income that limits our ability to consume. So the prices that we face essentially establish a trade-off for us that has nothing to do with our preferences, it has everything to do with how markets are setting prices. So the goods that we all buy, if we don't think about their value in monetary terms and dollar terms, we can think of them in like real terms. When we're talking about real terms in economics, we're talking about like their exchange value. So like how much are things worth in exchange for other things? And so there's this exchange set by the market called the market rate of exchange that we face when we're going into the market and saying we want to buy a bunch of stuff. Well, I only have so much income, and in order to get more of one thing, I have to get less of something else, and that exchange rate is based on the prices. So that's the second part of the model. It's setting up the framework to establish sort of like that market dimension to the interaction between an individual and what they could buy that gets them to that optimal point of consumption that we're ultimately trying to get to in the model. So once we set up the preferences and we set up the constraint, we'll take a break, we'll come back, and then we'll talk about the equilibrium in the model. The interaction of both that market rate of exchange and also like our own subjective rate of exchange. So the market expects us to, in order to buy more of one thing, to give up some of the other in some quantity, which will be specific based on what we talk about here. But we ourselves also have a rate at which we're willing to trade off things for other things based on our own preferences, what we prefer. So like, like you may want to go out to dinner more, and that means that you personally are willing to give up maybe, 3 Uber rides for a dinner, let's say. Whereas in the market itself, the trade-off that is set by prices requires you to give up only 2 Uber rides for one dinner. So there's your own subjective rate of exchange, and then there's a market rate of exchange. And at the point where they're equal is the point of optimal consumption. And so we have what's called the optimal consumption bundle. A consumption bundle is basically the combination of all goods and services that a consumer will consume. So if we think of everything that we consume in a month based on our monthly income, that is our consumption bundle. We will think of a simplified world in the model in which only two goods exist, and so consumption bundles will only be made up of two goods. But the simple case will translate to the more complicated case and more complicated applications. But that's ultimately what this model is. What I just talked about, like modeling preferences, modeling the restraints set by prices and income, interacting the two, modeling the optimal consumption bundle that somebody would choose, and demonstrating why that is an equilibrium for a consumer. And then the model beyond that, in this class at least, we'll look at a couple of sort of small applications of it. We'll look at comparative statics, kind of comparing what happens when things change in the market. Maybe prices are changing, maybe income is changing. How is that affecting the optimal consumption bundle? We'll look at that. And then there's a couple of other applications with the model that we'll look at towards the end. And ultimately, what the model is sort of like the logic and dynamics that underscore demand. So at the very end, I'll show how we can get from the model to a demand curve, the demand curve that we've been talking about in this class. And that connection is important because, like I mentioned in last class, like you can do a market analysis, like look at data on prices and quantity demanded in a particular market. You can then estimate an actual demand function for that market, and then you can go a step further using this model to kind of say, well, there's a representative consumer. There's a consumer that we can model as making the decision to consume in this type of market, and then we can deconstruct like the decision to buy less of something as price goes up into the individual components of that, which we call the substitution and income effect. So you can get a lot of insights into like consumer decisions with this model. It's a very powerful model. You'll see it in finance applications. You'll see it all throughout economics. You'll see it at central bank models. You'll see it at hedge fund models. You'll see it in any kind of sort of like entity that is trying to understand and maybe ultimately forecast aspects of the economy. You will see this model representing the consumer behavior in any of those models, and that captures a lot of like the consumption behavior of the economy, which then allows you to be more precise with the model that you're using to explain whatever, be it the price of an asset over time, be it the output of an economy over time, whatever. There's a lot of applications from this model, and as managers, we'll go through like the insights that the model can provide as we go through today's lecture. So that's basically what we're covering today. If you haven't been exposed to it before, just kind of you have to follow me as I kind of build up the logic of the model. Because if you miss a part of it, you're not really going to understand what we're talking about later with the model, because the model is going to be used to explain things. So if you don't understand the working parts, you're not going to understand the whole. You're not going to understand the whole model. So at the very least, try to kind of get it right now with me, and then if you kind of falter in your understanding, go home, review it again, whatever, do whatever you have to do to really get it as soon as possible. And that's my best advice to you. All right, any questions now before I get started on actually lecturing the material to you? All right, then let's jump into this. So chapter 4, the theory of individual behavior. Learning objectives will explain 4 basic properties of a consumer's preference ordering, how we model consumers' preferences, and their ramifications for the consumer's indifference curves, which are graphical representations of those preferences. We'll illustrate how changes in prices and income can impact an individual's opportunities. So again, given that things have prices and we have to use our income to buy things, we're limited to how much we can buy of anything. So that is our individual opportunities in the model, and we'll illustrate how that's affected by changes in price and income. We'll illustrate a consumer's equilibrium choice and how it changes in response to changes in price and income. So once we have everything put together, we'll do some comparative statics, compare the optimal consumption bundle, given that changes occur in the market environment. We'll separate the impact of a price change into its substitution and its income effects. So whenever a price changes, we know by the law of demand, people will consume more of something if the price goes down and consume less of it if the price goes up. And there's two reasons for that. One is that they're substituting away from the good they're buying to other substitutes, other related goods that they can substitute in place of the thing that's becoming more expensive. And the other one is the income effect, where you kind of have to have an understanding of like income in real terms. So like income um, uh, uh, as reflected by everything that you can buy. So everything that you can buy is your income. And if the price of something goes up, then it crowds out what you can buy. And so overall, you feel poorer in real terms. So that is the income effect of a price change. And of course, that effect is either really small, depending on how big a part of the budget something is, versus vice versa. So the income and substitution effects we'll see in the model can clearly be established based on a price change and the nature of a consumer's preferences that are represented by their indifference curves. We're going to show how to derive an individual's demand curve from the indifference curve analysis, and then the market demand curve from a group of individual demands. So we'll get to an individual's demand, how an individual responds to changes in price for a particular good, and then we can aggregate that, combine it with all the individuals that behave like that to get to that market demand curve that we've been working with thus far. And just quickly, a couple of applications that we'll talk about when we get to them. All right, so let's start setting up the consumer behavior side of the model. We'll begin here to develop a model to help us understand how consumers will respond to alternative choices that confront them. Just generally, a consumer, something you already know, is an individual who purchases goods and services from firms for the purpose of consumption, of course. In characterizing consumer behavior, there's two important but distinct factors that need to be considered. The first is their opportunities, what they can buy, and the other is their preferences, what they're interested in actually buying. So consumer opportunities represent the possible goods and services consumers can afford to consume, and the consumer preferences determine which of these goods will be consumed given what the individual consumer prefers. So the distinction is important. Again, like you may prefer to buy something, but it may not be in your opportunity set, so you may not be able to afford it. Keeping the distinction in mind, let's begin by modeling consumer preferences with a brief review of the utility concept. So in economics, we measure satisfaction with this concept called utility. So the utility of a consumer is a measure of the satisfaction the consumer derives from the consumption of goods and services. And essentially, it's a ranking system. So I get 5 units of utility, which are called utils, from drinking my water, and I get 8 units of utility from drinking my Diet Pepsi. Those numbers don't mean anything in and of themselves. They only mean something relative to each other. So 8 is greater than 5, so therefore I prefer Pepsi over the water. The numbers themselves don't mean anything, 5 or 8. They only mean something relative to each other. An individual's utility function gives the total utility generated by her or his consumption bundle. So it's a relationship between an individual's total utility and the amount of a good that they're consuming. I'll show you an example of utility function in just one second. Again, a unit of utility is known as a util. The marginal utility of a good or service is the change in total utility generated by consuming one additional unit of the good or service. It is also the slope of the utility function. So anytime we're talking about marginal anything, it's going to generally be the slope or derivative of the function. We haven't covered derivatives yet. I'll do a brief review of derivatives at the beginning of the second part of the course, because that's when we'll start using derivatives. In this first part of the course, we haven't done derivatives yet. I understand you've taken Math 103 and should already be able to do derivatives, but for those people that are a little bit rusty on it, I will cover it one more time for you. But nonetheless, up until this point, we've talked about marginal cost. So that's the slope of the total cost function. Marginal benefit, that's the slope of the total benefit function. So marginal anything is usually going to be the slope of whatever we're talking about, but also you can describe it, right? So here, the marginal utility is the extra amount of utility you gain from consuming one additional unit of a good or service. Now, everybody that consumes generally exhibits what's called diminishing marginal utility. So according to the principle of diminishing marginal utility, each successive unit of a good or service consumed adds less to total utility than the previous unit. So let's say you've been working all day, you're starving, you haven't eaten, you get home, you order a pizza. That first slice of pizza, magnificent. It is heaven. You love that slice of pizza. It's everything you've ever wanted. You eat that slice of pizza, you're not completely satisfied, you want more pizza. You eat that second slice of pizza, and you're happy. In fact, you're very happy, but you're not as happy as that first slice of pizza. Your marginal utility has diminished. The extra amount of satisfaction utility you have gained from that second slice of pizza is not as much as the first one because you already had a little bit of pizza. And the eighth slice of pizza will definitely not give you as much utility satisfaction as the first or second, but it will be positive. But it will not be a lot because the marginal utility diminishes as you increase your consumption of anything. This is a general rule. And again, everything in this model, everything that we assume is very general. There are always exceptions to everything that's presented in this class. There's always exceptions to most things you'll ever be presented anywhere. But the things you're being presented are being presented because there's a consensus about them that they capture a lot of like the characteristics of most situations. Yes, there's always exceptions. We call those outliers, and it's always acknowledged that they exist. But in general, what we're talking about, the relationship between what a person consumes and their satisfaction from what they consume, they exhibit diminishing marginal utility. So here's an example of a utility function. It's just utility as a function of just one thing that this person, Casey, is consuming, and that's clams. So she has been looking forward to the clam, all-you-can-eat buffet or whatever, gets that first clam, delicious, that clam, gets her a marginal utility of 15 utils. So she's going from 0 clams to 1 clam. She gets 15 utils from that first clam. So her marginal utility is 15. It's also the slope of the line that's tangent to this point, telling us that that first clam increases total utility by 15 utils. And then this curve down here plots the marginal utility. So, and it plots it between like where you started from to where you ended up, just to highlight the fact that you're gaining that extra utility as you're going from 0 to 1 in this case. So her marginal utility of that extra clam here is plotted as having 15 utils. Second clam, as we see, it does increase her total utility. So it has a positive marginal utility, but it is less than the first clam. In fact, if we look at the numbers here, that second clam gave her 13 extra utils. So her marginal utility was 13 utils, which brought her total utility up to 28. But it did diminish, right? It's 13, it was 15, and so you can see that the marginal utility curve that's tracking the marginal utility as we're moving from left to right along the utility function is decreasing because, again, it's exhibiting diminishing marginal utility, and that's how we capture it in graphical form. And you see that the curve is flattening out as we move from left to right. And again, that's because of diminishing marginal utility. So as we get to later units, you see like maybe like the sixth clam got her a marginal utility of 5 utils, the 7th, 3, the 8th, 1. Eventually it actually becomes negative, probably a bathroom situation problem thing that happened there. Yeah, so diminishing marginal utility, the marginal utility curve downward sloping to represent this principle. Total utility curve flattening out to represent the principle. All right, so having established some of the nuances of the utility concept, we now continue with more characteristics of the consumer behavior model. So we're going to assume that only 2 goods exist in the economy, just to simplify the world. So the assumption is made purely to simplify the analysis. All of the conclusions we draw from the 2 good setting remain valid even when there are many goods. So we're going to let X represent the quantity of one good and Y represent the quantity of the other good. And each combination of the goods will be within a consumption bundle, a combination of goods and services that a person consumes. So we're going to assume a consumer is able to order his or her preferences for alternative combinations of goods from best to worst depending on the level of utility gained from each consumption bundle. So in that simple case we just saw, utility was a function of just one good, which was clams. But moving forward, we're going to assume utility is a function of two goods, both X and Y, which we're keeping very general. And so consumption bundles will be made up of both differing quantities of both of these goods. You can have extreme cases where you have only good X and none of Y, or all of good Y and no X. And you can have cases in between where you have a combination of some X and some Y, all making up different consumption bundles. And all those consumption bundles can be ranked in terms of like utility value to the consumer. And so the consumer is able to rank all the consumption bundles. We'll let this greater than kind of curved greater than symbol denote this ordering, and write A is preferred to B whenever the consumer prefers bundle A to bundle B. If the consumer views the two bundles as equally satisfying, so you may have two consumption bundles that yield the same level of utility, and therefore a consumer will be indifferent between those two consumption bundles. We say that she or he is indifferent between bundles A and B, and we use the tilde, the kind of squiggly line there, to denote that. All right, so the preference ordering, this ordering of all the consumption bundles that embody a person's preferences over these two goods in this very simple two-good world that we are living in within the model, is assumed to satisfy four basic properties. The four basic properties, which I'll go through in turn and fine detail right now after I list them, is completeness, more is better, diminishing marginal rate of substitution, and transitivity. So let's go through those. The first one is completeness. So the first property that the preference ordering exhibits is completeness. And what does completeness mean? Well, for any two bundles, A and B, either A is going to be preferred to B, either B is going to be preferred to A, or the consumer is going to be indifferent between A and B. So the consumer is going to be able to rank every consumption bundle in terms of preferences, either one being better than the other being better than one, or them being equally preferred. That's what completeness, the completeness property tells us. By assuming the preferences are complete, we assume the consumer is capable of expressing a preference for or indifference among all bundles. If the consumer cannot express his or her own preferences for an indifference or indifference among goods, the manager can hardly predict the individual's consumption patterns with reasonable accuracy. So completeness is essential to being able to model preferences. Second property, more is better. In life, more is generally better. Sometimes it's not the case, but generally it is with respect to consumption, right? I mean, you can just see it in the economy. Like you can see that in like the way that the overall wealth in the world has been sort of polarized in a few hands, right? You have 1% of the world population, they own about 50% of the world's wealth. More is better. The opportunity, if the opportunity exists for some to get more, they do, generally. There's exceptions to that, of course, but generally when we're talking about consumption, we're talking about wealth, more is better. And so that property needs to be included. So if bundle A has at least as much of every good as bundle B, but more of some good, then bundle A will be preferred to bundle B. If more is better, the consumer views the products under consideration as goods. So that's why we call these things that people consume goods, because we generally assume that the things that they consume, they are interested in consuming more of, and that's better than consuming less of them. But if you have the case of a situation where a consumer wants less of something, then we call that a bad. All right, so graphically, this implies that as we move in the northeast direction from the origin on the XY plane, the bundles, the consumption bundles that the consumer might want to consume are going to be more, are going to be preferred more to consumption bundles that are closer to the origin. I'll be more specific about that in a second. All right, so how we can represent these properties graphically and therefore represent a person's preferences graphically is via what's called an indifference curve. It is the geometric representation of the principle in which along the curve every consumption bundle yields the same total utility. So remember, with Casey's utility function, it was a function of just one good. So The total utility was on the y-axis, the clams was on the x-axis, and as she increased her consumption of clams, her total utility increased but flattened out. Right now we're talking about a case where utility is a function of two goods. So when you have something that's a function of two goods, in this case, the two goods are variables, right? They can change, the quantity of each can change. You're going to have a three-dimensional relationship. Whenever you have a three-dimensional relationship, you can't represent that graphically on your standard XY plane. You need a third dimension. So generally you have what's called the z-axis that will come out from the flat plane, and it'll represent the height of this relationship. So a three-dimensional relationship will have a three-dimensional shape graphically. The utility function, when we're talking about two goods, is going to have like a bowl shape, like just a rounded edge that kind of converges to like some point at the top, right? You can kind of think of the hat in this way. It's not perfect, but you can kind of think of it as like a bowl. So let's say you have the x-axis down here and the y-axis here, which represents like the flat plane where the hat lays on, and it represents the amount of x and the amount of y that's consumed. The height of the hat represents the utility. So let's say you were to slice the hat at some level. So you slice this bowl at some level. So this right here is like a quarter of the bowl. So here's the back, and then you get the kind of like the rounded edge here, and it's kind of converging to the top. It's a three-dimensional shape. It's not a perfect representation of it, but it's adequate for our purposes. So utility is the height of the bowl. Let's say you were to slice this utility function of two goods at some level. So let's say we sliced it at the level where utility is 30. What you would get is this trace sort of rounded edge, which if we flatten it down, we can just have it be this curve on the XY plane, again representing a plane where you have some of good X that can be consumed and some of good Y that can be consumed. And so any point on this plane represents a consumption bundle of those two goods, a combination of the two goods. So if we slice our utility function bowl at some level, let's say at a level where utility is 30, and then flatten that rounded edge, we get this curve here, which we call an indifference curve. And it represents all the consumption bundles that yield the same level of utility. So here's a consumption bundle of here that has a lot of Y and a little bit of X. Here's a consumption bundle that has less Y and a lot more X. Both of those consumption bundles, along with all the other consumption bundles along this curve, give the consumer the same amount of satisfaction. So along an indifference curve, you're going to have the same level of utility for all consumption bundles, and therefore a consumer will be indifferent between any consumption bundle along that indifference curve. Let's say we were to slice our utility function at a slightly lower level that corresponded to a height of 20 utils. Again, you get that rounded edge, you flatten it down, we get this other indifference curve. This one represents consumption bundles that all yield a level of 20 utils. So the utility equals 20 for all consumption bundles along this indifference curve. So here's a consumption bundle up here. It yields 20 utils. Here's a consumption bundle down here yielding 20 utils. And thus the consumer is indifferent between those two consumption bundles along with all the other ones that are embodied in this indifference curve. The consumer is indifferent between all consumption bundles along it because they all yield the same level of utility. In this case, 20 utils. Now you could slice this utility function at any level, and therefore you do have an infinite amount of indifference curves. Here we don't see them all, but as we move closer to the origin here, closer to 0, you're going to get rounded edges that are lower and lower along this bowl, which are going to represent lower amounts of utility. And as we get higher up the bowl and we slice it higher up, we're going to get higher levels of utility, and therefore we'll get indifference curves that have consumption bundles that yield higher levels of utility than those closer to the origin. So as we move away from the origin, indifference curves will have consumption bundles that are preferred to those that are closer to the origin. All right, so we know the consumer is indifferent between any consumption bundle along an indifference curve, and this tracing of all these edges of the utility function make up what's called the indifference map, and it represents the entire utility function of an individual as a collection of indifference curves in which each curve corresponds to a different total utility, and it is a graphical representation of a person's preferences. The shape of the indifference curve depends on the consumer's preferences. So the curvature of the indifference curve represents how a person feels about the trade-off between one good versus another. So depending on how we specify how this will look, we can capture different preferences for different consumers. But in this class and in this lecture, we'll just assume that everybody has the same preferences and that they all kind of look like this. So this is just one indifference curve. An important way to summarize information about a consumer's preferences is in terms of the rate at which a consumer is willing to trade off one good for another along an indifference curve, which is called the marginal rate of substitution. The marginal rate of substitution is the slope of an indifference curve, and it's the rate at which a consumer is willing to substitute one good for another and still maintain the same level of utility. So again, the slope of the indifference curve is the marginal rate of substitution. So let's focus on what happens when we move a short distance down the indifference curve, trading off a small increase in x in place of a small decrease in y. So we're assuming the consumer starting up here, this was their consumption bundle, and then they decide, you know what, I want to consume a little bit more of x, but to consume a little bit more of x based on my subjective preferences, I have to give up some y. And so as I move along here, the rate at which I have to trade off y for x is the marginal rate of substitution. So in general, the change in total utility caused by a small change in consumption of a good is going to be equal to the change in consumption multiplied by the marginal utility of that good. So as we're consuming more of x, we're going to consume a little bit more x, which is going to carry some utility value, some satisfaction value. And to do that, we have to give up some of y, which is also going to carry a loss in some satisfaction value, right? Some marginal utility will be exchanged from x to y, from y to x. So let's let the marginal utility of good x equal mux. So again, this is the same concept that we talked about in Casey's utility function. Each additional clam she ate gave her marginal utility, right? Extra utility from consuming an additional clam. That's what we're talking about here. But we're talking about the relationship between this very general consumer and the satisfaction they gain from additional units of x that they consume. So we represent that as mux. If we let the marginal utility of y equal muy, and we let a change in the consumption of good x, so going from this consumption bundle to this consumption bundle, there's going to be a change in how much the consumer consumes of x, which is an increase. So the change in the amount of qx is represented as the triangle change. Triangle again represents change mathematically of qx. So a change in the consumption of good x will carry a change in total utility equal to that extra amount of x that's consumed times the marginal utility that's associated with that extra amount of x that's consumed. So there's going to be a little bit more consumption, and that's going to carry some utility value, right? So the marginal utility of that extra amount is going to then affect the total utility of the consumer. In order to consume more of x, this consumer has to give up some of y. So we'll let the change in the consumption of y be represented as the change in qy, which will carry a change in total utility equal to muy, the marginal utility of y, times that amount of y that's being given up. So again, going from here to here, you're giving up some y, which means you're losing some satisfaction from that, but you're gaining some satisfaction from the extra x, which is this amount here. This is what you're gaining, this is what you're losing. As we know, along an indifference curve, as you're moving from one consumption bundle to another, total utility has to remain constant. And so therefore, along the indifference curve, these two values have to necessarily be equivalent in order to maintain that property. So the extra amount of utility you gain from consuming extra X has to be equal to the amount of utility you lose from consuming less of Y. The negative is meant to capture the fact that there is a trade-off there. You're losing some marginal utility from lowering the amount of Y, and you're gaining some utility from consuming more X. All right, so to figure out how this translates into the slope of the indifference curve, the marginal rate of substitution, we can rearrange this expression here to get like a general specification for a slope, which is the change in Y over the change in X. So here's our starting point. I'm going to divide both sides by MUY to get that over to the right. I don't expect you to be able to derive this, but I do expect you to know what the result means. All right, so you divide both sides by MUY here, and now you want to get the change in QX on the left, so you have the change in QY over the change in QX. So you divide both sides by the change in QX. And that gets us to this expression for the slope of our indifference curve. So the slope of the indifference curve can be expressed in the model as the ratio of the marginal utility of the good on the x-axis to the marginal utility of the good on the y-axis, just given what we know about the characteristics of the model and the fact that we derived it in the way that we did. So people often get confused by this because they forget that the marginal utility of x needs to be on the numerator. Remember, normally when you look at just a general slope mathematically, you have the change in the quantity of y over the change in the quantity of x. But given what the meaning that we've added to the model, that's allowed us to express the slope of this particular curve as equal to the ratio of the marginal utility of the good on the x-axis to the marginal utility of the good on the y-axis, which kind of flips what you normally would think of a slope. So it's just something you have to kind of keep track of, or else it will confuse you later. And of course, that is our marginal rate of substitution. The left-hand side is an approximation to the slope of the indifference curve. It's the rate at which the consumer is willing to trade x in place of y. The right-hand side is the ratio of the marginal utility of good x to the marginal utility of good y. So the marginal rate of substitution associated with moving from point A to point B differs from the rate at which the consumer is willing to substitute between two goods moving from B to C. So we see that if the consumer is at point A and they are consuming 6 units of Y and 1 unit of X, in order to consume 1 more unit of X, they have to give up 2 units of Y. So you see that the new consumption bundle is made up of 2 units of X and 4 units of Y. But to gain an additional unit of X after being at this consumption bundle B, consuming 2 units of X, to gain that third unit of X, the consumer only requires giving up 1 unit of Y. So in moving from B to C, the consumer gains 1 unit of good X, but now he or she is willing to give up only 1 unit of good Y to get the additional unit of X, which is different than the trade-off she was willing to make from point A to point B. The reason is that indifference curves satisfy the property of diminishing marginal rate of substitution. Getting us to the principle of diminishing marginal rate of substitution. As a consumer obtains more of good X, the amount of good Y he or she is willing to give up to obtain another unit of good X decreases, as we just saw as I moved from point A to point B and then from point B to point C. So the reason for this is because of diminishing marginal utility. So the diminishing marginal rate of substitution is because of the principle of diminishing marginal utility, which I introduced to you and covered in fine detail when we were talking about Casey and her clams, right? Each additional unit of clams gave her less satisfaction than the prior unit consumed, right? So what that tells us is that each additional unit of X consumed is going to be valued less as the consumer consumes more and more of X, which means that in terms of trade-off value, then the value of the first unit of X is going to have a higher trade-off value than the second unit of X because of diminishing marginal utility. The second unit of X doesn't give the consumer as much total utility as that first unit did, right? So the change in marginal utility diminished going from that first unit to the second unit. And so going from 0 to the first unit, she required a lot of y to be given up, in this case 2 units of going from the first to the second, she required 2 units of y to get that second unit of x, because she values x quite a bit in terms of utility. But then her marginal utility diminishes as she consumes that third unit of x, so therefore she only requires giving up 1 unit of y. And that is why the indifference curves exhibit the property of diminishing marginal rate of substitution. The slope of the indifference curve flattens out, representing the fact that the rate at which the consumer needs to be compensated for consuming 1 additional unit of the good is diminishing as the consumer consumes more goods, in order for the consumer to remain as well off as they were before, meaning that they are still along the indifference curve. So when a consumer has diminishing marginal utility, consumption of another good generates a smaller increase in total utility than the previous unit consumed, as I mentioned already. The assumption implies that indifference curves are convex from the origin. So the fact that the individual's relationship to each good exhibits diminishing marginal utility creates the diminishing marginal rate of substitution along the indifference curve, which gives it this shape, which we say in mathematics is convex from the origin, also known as concave up in mathematical terms. Another way to describe it is like it's bowed out from the origin. It's kind of like a bow that you use to shoot an arrow, but it's kind of like away from the origin. All right, and finally, the fourth property is transitivity. So the fourth property says that for any 3 bundles, let's say A, B, and C, if A is preferred to B and B is preferred to C, then A must be preferred to C. Similarly, if the consumer is indifferent between A and B and the consumer is indifferent between B and C, then the consumer must necessarily be indifferent between A and C, transitivity. All right, so those are the 4 properties. The implications of these 4 properties: completeness, more is better, diminishing marginal rate of substitution, and transitivity are conveniently summarized in the figure, which depicts 3 indifference curves. So the indifference map, again, is how we represent a consumer's preferences. It embodies all of those properties that we just discussed, and it's the best we can do to establish the most general case of preferences of a person, something very abstract, into something tangible. So every bundle on indifference curve 3, as we know, is going to be preferred to every bundle on indifference curve 2, and every bundle on indifference curve 2 will be preferred to every bundle on indifference curve 1, as we know, because of what each curve represents, a level of that utility function. Also because of the property of more is better, right? Consumption bundles up here have more of X and Y, the consumption bundles here, the consumption bundles here. So the 3 indifference curves are convex. Because they're convex, they do not cross. And again, curves farther away from the origin imply higher levels of satisfaction than curves closer to the origin. So all this is about really having a profound understanding of what these indifference curves are, how we are able to capture general preferences in a mathematical relationship that can be expressed graphically as an indifference map. All right, so that's the preferences part. Now let's jump to the constraints part, the part that is imposed upon our preferences, that limits our ability to satisfy our preferences, because we know that more is better, and therefore we would want to have as much of everything as possible, but fortunately we live in a world where that's not possible. Constraints that are created by our income and the prices we face stop us from being able to consume as much as we want, so we need to be able to consume a consumption bundle that we prefer the most, but is most affordable to us. All right, so in making decisions, individuals face constraints, right? Legal constraints, time constraints, physical constraints, and of course, budget constraints, which is what we're going to be talking about here. So we'll examine the role that prices and income play in constraining consumer behavior via the budget constraint. So simply stated, the budget constraint restricts consumer behavior by forcing the consumer to select a bundle of goods that is affordable. We'll let M represent the consumer's income. We've been using M for income, so we'll be consistent with that notation, which again can be any amount. We'll let PX and PY represent the prices of good X and Y respectively. And we'll let X and Y represent the quantities of good X and Y respectively. Given this notation, the opportunity set, also known as the budget set, may be expressed mathematically as this relationship here. So there's a total amount of X that's consumed in value, so the amount of X times the price, plus the total value of Y consumed, that could be consumed. So the amount of Y times its price, and that's going to be less than or equal to the amount of income the consumer has. So all the combinations of the two goods, all the consumption bundles embodied in this budget set are the consumption bundles that the consumer can afford given her income. The consumer's expenditures on good X plus her expenditure on good Y do not exceed the consumer's income. That's what that statement is telling us. If the consumer spends her or his entire income on the two goods, then the equation will hold with equality. That is the case we'll consider in this class. We won't consider the case where the consumer does not expend all of her income because that involves savings, which the model can account for, but it creates more intricacies that are not necessary for us to understand what we're trying to get in this class. So we'll always assume that the consumer is spending all of her money. So this will always hold with equality here. Now graphically, the budget set is constrained by what is called the budget line. The budget line represents the bundles of goods that exhaust a consumer's income. It's the bundles that the consumer buys and spends all her income on versus bundles that maybe cost a little bit less than her entire income. So those bundles along the line represent the ones that will exhaust her income. It's useful to manipulate the equation for the budget line to obtain an alternate expression for the budget constraint in your standard slope-intercept form for a line. So that means solving for y in terms of x here. The slope-intercept form of an equation of the line with slope little m, just to kind of differentiate it from the income. M is just slope. And I use that just to kind of be consistent with what you guys have done in your 103 course and your algebra courses. And y-intercept is b. So y equals mx plus b is a slope-intercept form. We're trying to get this into this form. So again, we're going to solve for y in terms of x. So I'm going to subtract px times x from both sides. I don't need you to learn how to derive this, but it should be something that you should be able to do. And then I'm going to divide both sides by the price of y to solve for y in terms of x. And that's going to get me to this expression here, which is the slope-intercept form of the budget line. So we see that the intercept is m over py, so it's income divided by the price of y, basically the most amount of y that can be consumed if the consumer only spent her money on good y. And then we see that the slope of the budget line can be represented as the ratio of the price of good x to the price of good y. Y is a linear function of x with a vertical intercept m over py and a slope of negative px over py. All right, so we can plot that line as I did here in our xy plane. Again, the y-axis represents the amount of good y that's consumed. The x-axis represents the amount of good x that's consumed. So this is the consumer's budget constraint. The budget set is the entire triangle that's bounded by the line. And it represents, again, the opportunity set, all the consumption bundles that are affordable to the consumer. So if any combination of goods x and y within the shaded area, such as G, represents an affordable combination of x and y. If the consumption bundle is within the triangle, it represents, again, bundles that are not exhausting all of one's income, but are affordable. If you have a bundle like H that's outside of the triangle, that's a bundle that's not affordable, right? It's made up of some of Y and some of X, but given prices and one's income, the consumer cannot afford that bundle. And the line itself is the budget line that we just solved the equation for. And again, it is the upper boundary of the budget set, and it represents all the consumption bundles that exhaust the consumer's income. So all the bundles on that line represent combinations of goods X and Y that take up all of this consumer's income. If the consumer spent his or her entire income on good X, the expenditure on good X would exactly equal the consumer's income, as the line tells us. So if the consumer was only to consume good X, that means that the amount of Y she consumed would be 0. So this is still our expression from before. And if we divide both sides of that by the price of X, we get the most amount of X that the consumer can afford if she only consumed good X. Graphically, where does that lie on our line? Here? The horizontal intercept, right? It's a horizontal intercept of the line. It represents this consumption bundle here where the consumer is consuming 0 Y and just X. So that's that point there, our horizontal intercept, M divided by PX, the most amount of X that the consumer can buy. Similarly, if the consumer spent her entire income on good Y, expenditures on Y would exactly equal income. So it would be equal to PY times Y. Here, the amount of X is equal to 0, so that drops out. And so income is equal to the value of all Y that can be consumed. You divide both sides by the price of Y. And then you get, again, that Y-intercept, the most amount of Y that can be consumed. Income divided by the price of Y. So that's our vertical intercept for our budget line. Now, based on what we did to get the budget line into that slope-intercept form, we know that the slope of the budget line can be expressed as the negative ratio of the price of X to the price of Y. And it represents the market rate of substitution between goods X and Y. So the market rate of substitution is the rate at which one good may be traded for another in the market, and it is also the slope of our budget line. Another way to understand it is to think of it in terms of opportunity cost. So let's say we're thinking of the opportunity cost of consuming only good X. So if we only consumed X, then the consumer would be buying this consumption bundle here. In order to consume just good X, that means they have to give up all of consuming Y, right? So the opportunity cost of consuming X is consuming all of Y, right? Opportunity cost is the value of everything that has to be given up in order to do something, right? In this case, to consume all of X, we have to give up all of Y. So the opportunity cost is not to consume only good Y with one's income M. That is what you're giving up. So the opportunity cost of only consuming good X is going to be in terms of Y, so that's going to be on the numerator here. So the total possible Y consumed over the total possible X consumed. In order to consume all of X, you have to give up all of Y. So that is equal to the Y-intercept over the X-intercept there. So you have M over the price of Y divided by M over the price of X. So you've got a ratio divided by a ratio, which is just from properties of ratios, equivalent to the top ratio divided by the reciprocal of the bottom ratio. So you got the top ratio times the reciprocal of the bottom ratio. So you have Px over M there. The M's cancel out. And of course, the expression we get is the one we have here, which again gets us to that market rate of substitution and just demonstrates that what it's representing is the opportunity cost of consuming one good in terms of the other good. What are we giving up in terms of the other good to consume the one good? It's also known as the relative price of good X to Y. So let's look at a numerical example just to solidify your understanding of what I'm talking about here. So to gain more insight into this concept, consider the figure which presents a budget line for a consumer who has, let's say, $10 in income and faces a price of $1 for good X and $2 for good Y. If we substitute these values, px, py, and m, into the formula for the budget line, so here's our formula for the budget line, we get income 10 divided by 2, so the most amount of y that the consumer can consume is 5 units, so that's going to be the vertical intercept, minus 1 half x. We know that the slope of the budget line is the market rate of substitution. So basically what this is telling us is that each additional unit of x requires you to give up half a unit of y in the market, right? Based on the prices that are set in their individual markets, right? So there's a market, a demand, and a supply curve for good x. There's a price being set for that. It's, in this case, going to be $1. There's a demand and a supply curve for a good y. There's a price being set in that market. It's $2 in this case. So the rate at which you are able to trade x for y in the market is 1x for half a y given the prices. So that's the market rate of substitution. And then you can look at it the opposite way. What do you have to give up of x in order to get y? Well, you just take the reciprocal of this. So in order to gain an additional unit of y, you have to give up 2 units of x. Another way to think about it is the opportunity cost of consuming 1 unit of y is 2 units of x. The opportunity cost of consuming 1 unit of x is half a unit of y. So that's the market rate of substitution. So again, that's negative 1/2 there. We observe that the vertical intercept of the budget line is 5, of course. The reason the slope of the budget line represents the market rate of substitution between the two goods is as follows. Suppose a consumer purchased bundle A, let's say, which is made up of 3 units of good y and 4 units of good x. If the consumer purchased, let's say, bundle B instead, which is made up of 4 units of y and just 2 units of good x, she would gain 1 additional unit of good y. In order to gain an additional unit of y, she had to give up 2 units of x. So for every unit of the good y the consumer purchases, she has to give up 2 units of good x in order to be able to afford the additional unit of good y, the market rate of substitution, which you can get from the slope of the budget line. So the way this model works is exactly the same as the production possibility frontier that you may remember from your micro and macro courses. That represented all the possible combinations of goods that could be produced by an economy if there were only 2 goods in the world. Basically the mechanics of this work exactly like the mechanics of that. In case you remember, it might help you to understand this better. Not that it's hard to understand this, because it's not. If you haven't been tracking everything I've been saying, then maybe you got lost at some point. But just go back to the beginning, follow the lecture, and then you'll get it, because it's not difficult. We're just looking at the equation of a line. But what it also tells us is how powerful like a simple line can be in terms of like the information that it can embody, and ultimately what it can provide us in terms of insights about whatever we're applying it to. All right, so the market rate of substitution is, of course, equal to 1/2, which is the slope of the budget line. In terms of the relative price perspective, x is worth half a unit of y, and y is worth 2 units of x. So there's different ways to look at it, but it's ultimately all the same thing. In the 2 good case, the relative price are reciprocals, as I mentioned. All right, let's do a couple of changes of some things, see how that affects the budget line, and then we'll take a break. So the first thing we'll consider is a change in income. So we know that the consumer's opportunity set depends on market prices and the consumer's income. As the parameters change, so will the consumer's opportunities. So we'll now examine the effects on the opportunity set of changes in income by assuming that the prices remain constant. So prices aren't changing, only income will change right now. So we know that the slope of the budget line is the market rate of substitution, which is the ratio of the prices representing the trade-off one must make in markets for one good in terms of another. Therefore, when income changes, that won't change, right? So what does that mean for this line then? If income were to go up and down, what would that look like in terms of this line? Right, it'll just shift out or in, right? And it'll be like a parallel shift, like the slope, the market rate of substitution will be intact, right? So suppose a consumer's initial income is some amount M naught. So we're going to consider what happens if income increases to M1 while prices remain unchanged. So remember, you can always just think of the one easy way to kind of think about changes of these things is just kind of think about what's happening to my intercepts. So we know that if your income is going up and the price is remaining the same, then you can buy more of everything, right? So both of my intercepts would increase, which would shift the line out. We know the slope of the line is given by the negative ratio of the price of the good on the x-axis to the price of the good on the y-axis. So under the assumption that prices remain unchanged, the increase in income will not affect the slope of the budget line. However, the vertical and horizontal intercepts of the budget line both increase as the consumer's income increases because more of each good can be purchased at the higher income. Therefore, an increase in income will shift the line out in a parallel fashion. Again, this represents an increase in the opportunity set, right? The consumption bundles that the consumer can afford to buy, either those that exhaust all of her income that are on the line or those that she can afford that are on the line and within the triangle. Similarly, if income decreased from M0 to M2, the budget line would shift towards the origin, and it would restrict the opportunity set to a smaller one, right? Because now income is less. Obviously, the consumer can afford less of everything. But the prices have remained the same, so the relative price, the market rate of substitution, remains intact. All right, something else that could happen is a change in prices. So suppose the consumer's income remains the same, but that the price of good X will decrease from some price P0 to some price P1. Also suppose the price of good Y remains unchanged. So the reduction in the price of good X changes the slope, making it flatter than before, right? The numerator becomes smaller, so the slope becomes smaller. That means that now, in order to get one additional unit of X, you need less of Y, right? The market rate of substitution has decreased because the price of X has decreased. So X is now worth less in exchange value. Since the maximum amount of good Y that can be purchased is M divided by Py, our Y-intercept, a reduction in the price of good X does not change the Y-intercept of the budget line. But the maximum amount of good X can be purchased is now going to be greater because now, of course, as the price of X goes down and you divide your income by a smaller price, you're going to get a bigger amount of what you can buy of that good that now has a cheaper price. So that's going to be represented by an increase in the X-intercept, which will rotate the budget line outward along the X-axis. In this case, because we're dealing with the price of good X, right? So the ultimate reduction of the ultimate effect of a reduction in the price of good X is to rotate the budget line clockwise. If the price were to increase, then you would have our income divided by a higher price, which would mean that the consumer can buy less now of the good, which means that the intercept will shift in and the line will become steeper. It also means that the market rate of substitution will increase, meaning that for each additional unit of X that you want to purchase, you have to give up more of Y because now X costs more. So the exchange rate becomes higher, embodied in the slope of the line. So if it were to pivot in, then the slope would be larger in absolute value, representing a higher market rate of exchange for one unit of X. It is now worth more in terms of Y. All right, congratulations. You got through half of this. We're going to get to the second half when we get back. Let's come back at 8:30.